A pharmacist is to prepare 15 milliliters of a special eye drop for a glaucoma patient. The eye drop solution must have 2% active ingredient, but the pharmacist only has 10% and 1% solution in stock. How much of each type of solution should be used to fill the prescription? To begin with, I'm going to look at my two solutions I have in stock, which are 10% and 1%. I'm going to label these two solutions X and Y. Well, the pharmacist needs 15 milliliters, so I know that how many ever milliliters of X I use, of my 10% I use, plus how much ever I use of my 1% or my Y has to equal 15 milliliters. Well, I realized that the 2% solution that he's trying to create would be 15 milliliters times 2%, or in other words, 0.3. So I know that 10% of my X solution, I'm going to add that to 1% times how much ever of my Y solution, must give me those 0.3 milliliters. This is the tricky part. I have two equations here with X's and Y's. I'm going to solve this equation for Y. This will allow me to substitute in 15 minus X for Y. Thus I can rewrite my equation as 10% of X plus 1% of 15 minus X, again that's Y, must equal 0.3. Solving this equation then, 10% of X plus distributing this out would equal 0.15 minus 0.01x equals 0.3. Combining my x's, I get 0.9x equals, subtracting 15 over 0.15, I get 0.9x equals 0.15. Thus, x equals 0.15 divided by 0.9, or approximately 1.67 milliliters. Looking back, again, I realize my X is 10%, so this is about 1.67 milliliters of 10% solution. Plugging that 1.67 back in, I get approximately 13.33 milliliters of my 1% solution. So 13.33 milliliters of 1% and 1.6 milliliters of my 10% are my final answers.